Hi everyone, this is Ashnath Kodhari here. So in this particular video, I'm going to be discussing the indicative solutions for CS2 A for IAI July 2022 session. So before starting with the discussion of it, I would just like to inform all of you that the batches for the IAI December 2022 session at Finatics has started. We are conducting classes in live online mode, live offline mode, as well as pre-recorded lectures are being provided. So a student will have access to all these three, and according to their flexibility, they will have the control to self-pace their course. Along with that, all other preparatory resources, be it the material, past year questions to practice, mock examinations, mathematical typing, paper B practice questions, all of these, would be provided to our students. So in case you're looking to join our classes, do reach out to us as soon as possible. We firmly believe that starting early remains one of the biggest drivers for success. As such, as soon as your exams are over for this July session, do start with your preparation for the December session. Now, overall, with respect to the difficulty of paper uh, in CS2 A this time, I will say overall the paper was easy. Although the MCQs this time were way less, what had come in the previous sessions, so that might have been a challenge. The amount of, let's say, mathematical typing in this particular paper, I would feel that it was slightly more compared to the past II papers. Also, although I found out the questions to be easier because they were very similar to what have been there in the institute material or even let's say the past papers of IFOA. But there were two major printing errors as per my understanding in this question, and that could have resulted in students getting confused, and that was probably 25 marks, two questions together, one of time series and another of reinsurance, I would say. So I will be coming to those particular questions as well. Apart from that, I would say, the students who had prepared well, they had practiced extensively by, solving material questions as well as the past year, at least IFOA questions. They should have been able to, attempt a high number of marks in this particular paper. So now let's get started. The first question is a 6 marks, very direct based question from risk model, where the number of claims can either take the values 0, 1, or 2, and claim amounts can take either the value 10,000 or 1 lakh. So there are going to be these cases. S can take the value 0, 10,000, 20,000, 1 lakh, 1 lakh 10,000, and 2 lakh. And the respective probabilities have been highlighted over here. Again, before progressing further, as always, if you find out any sort of errors, be it conceptual or numerical errors, please feel free to reach out to us through comment section of this particular video. We shall be putting in the rectifications, in the comment section itself. So do check the comment section as well. In case, we do identify certain errors, we would be coming up with the corrections of same through the comments section. The question two, it was calculating the exposed to risk. So, these are there. 10 lives are there. I have written down the months 1, 3, 5, 7, 2.5, 12, 7.5, 3, 5, 1. And it's coming out to be 47 months. In years, you can write it as 311 by 12 years. Now, next part is calculating the hazard rate. Note that there are 4 deaths, but one death which is happening is not happening in the interval of 50 to 51. So we ignore that. Apart from that, D takes the value 3. So it's coming out to be 36 by 47 when working in terms of in units of years. And we know that assuming this force of mortality to constant between 50 to 51, Q50 can be written as 1 minus e to the power minus mu 50. Then we have question 3, again fairly straightforward, mu x is equal to bc to the power x. We have the values of 1p55 and 2p55. So I express these and, on solving them, C is coming out to be 1.1020178843 and D is coming out to be 3.428 into 10 to the power minus 5. Next, we have question 4, which is where there was an error. So the question 4, it's stating, it follows a Burr distribution with density function. 0.4 plus x to the power 0.4 to the power alpha plus 1. Okay, so now if we'll take a look at tables and if we'll see the formula, it is something of this form. alpha lambda to the power alpha into gamma into lambda to the power alpha x to the power gamma minus 1 lambda plus x to the power gamma alpha plus 1. So if I compare, alpha plus 1 over here and what I get over here is alpha plus 1. Fine. Instead of lambda, I have zero point 0.4. Fine. And x to the power gamma. And here what I have is x to the power zero point 0.4. So you might think that gamma is zero point 0.4 over here. But if gamma is zero point 0.4 over here, then there should have been a zero point 0.4 over here as well. Because in numerator, what we have is alpha into gamma into lambda to the power alpha. And what I have is lambda to the power alpha. Again, I have a zero point 0.4 over here. Right, which is fine. And then to the power alpha. And then I have x to the power. We have x to the power gamma minus 1. So clearly this x to the power zero point 0.5 also doesn't make sense here, because if this is zero point 0.4, this should be minus 0.6. If this is 0.5, this should be minus 0.5. So there are a lot of inconsistencies over here. This term is separate, this term is separate, this term is separate. So, one way to solve it is stating your assumption. If you have done so, I hope so, IA would be giving due marks to all of the students. And I'm not sure, how they would go on marking if anyone student uses this particular PDF only. Because in the first place, the PDF is inconsistent. Again, if anyone has used this PDF, IA might give them due marks since it's a printing mistake. So ideally, you should have been able to observe this. But even in case you haven't, you might come up with a different result. So on that, I'm just showing you according my assumption. I have assumed that this particular parameter is taking the value 0.5. That is my assumption. Assume that gamma is 0.5 and I have worked accordingly. So this is the fx, then I have the likelihood. 10 data sets I have. For 7 of them, I know simply that they are greater than 234. So it's probability x greater than 234 to the power 7. And I get this particular term. And then you can keep proceeding, find the log likelihood, its first derivative, second derivative, and so on. So let's ignore the answer over here, because again, it might not be relevant. Different students might have taken different assumptions. In part 2, we need to find the median. So fx is equal to 0.5. This formula of fx, again, I have missed over here. There should be an m to the power 0.5 over here. Let me just check if I have corrected the same. Yeah. Here, if you see, it's 1 minus lambda by lambda plus m to the power gamma whole to the power alpha is 0.5. Substituting all this, I'll be getting, and m is 205. How? We have total 17 claims. So if you arrange them in an orderly way, the ninth claim, it's 17. So the ninth claim, if I'm not wrong, it should be coming out as 205 only. Rather, if I see here, it's actually the eighth claim. So again, just now I've identified. Actually, if you arrange it, then the ninth, it's 17 claims. So, the ninth one will be the median. So it should actually be 217 over here. So when you can put the value of 217 and correspondingly find the value of alpha over here. Please ignore this answer. This is a wrong one because I have considered 205, but it actually should be, 217 over here. So you see, such silly mistakes do happen. Like even when I am solving probably, I took the eighth value by mistake instead of the ninth value. So part 2 is percentile, and then part 3 is the normal explain or the comments part, why the estimates are different, because these are two different methods we are applying. Question 5 is from machine learning. These are direct bookworks, so I'm not covering them as such in this particular video in detail, as these are direct bookworks. Question 6, again another question. A major printing error. So first of all, if you look at the structure of question 6, this question has been tested in the past year. I'll be stating the year as well, which particular paper, which particular term. So here, if you see, it's 1 minus b cube into 1 minus alpha plus beta b, so on. Actually, what I think they would want this question to be, to make the other parts a bit more logical or, sensible, is this. This 1 minus b whole cube will be outside, and then this is the entire term. So there might be somebody who might be doing the mathematical typing, they might have interchanged this bracket sign, one sign, this bracket sign, instead of being over here, they had taken over here itself. So again, it's very difficult for students, but the ones, who had prepared, they could have identified it. I honestly, the moment I saw the question, I was able to identify, oh, this is a similar question to, what has been asked in the past. And then when I again looked at it, I'm like, no, something looks wrong, because I mean, this won't be solved in the way they have given. And this is the particular year I'm referring to, CT6 paper, September 2012, question 9. Note that this is for IFOA. So you can go to the IFOA website, take a look at the CT6 September 2012 paper, and just take a look at question 9, you will find it. Alternatively, if you have revision notes, you would find it there itself. So, I mean, thereafter, the entire procedure is same. So, one could look at this particular question and the remaining parts of this question can be solved. So, again, here, how would I go about marking it? It's on it. For this part, I'll say, I mean, for part one only, in their particular form, it doesn't really make any sense. I mean, here students would have had to assume this or maybe something else, then it would have made sense. Else, once examiner report is out, we might be able to make sense out of it. But this was the second printing mistake which I was able to identify. So 15 marks question over here and 10 marks question over there, making a total of 25. Then question 7, it's on let's say reinsurance. So X follows Pareto alpha comma lambda. We have the mean, we have the standard deviation, and hence the variance. So first I calculate the parameters over here. What I'm getting is alpha is 72 by 11 and lambda is 61,000 by 11. Then I compute the probabilities of X greater than 3300 and 2200. These are the probabilities which I'm getting. And then expectation Z, this is the formula which we actually have for the expectation of a Pareto distribution. Again, the derivation of same I have not covered. You could derive it and you'll see that this is the result we have for a Pareto distribution in case of excess of loss reinsurance. So for first arrangement, I'm getting 75. For second arrangement, I'm getting 156 over here. And now part 3 is, suggest, which is the most suitable reinsurance arrangement. So you need to see the value for money. First one, you can just think of proportion wise. You are expected to pay 75 amount per claim, not for all 500 policies, per policy, I will say. And when the retention limit is 3,300, okay, and premium is 3,000. So you can think 75 you need to pay as a proportion of 3,000. Again, note, these are not comparable. 3,000 is for the entire 500 policies. You can maybe think in this way, it's actually 6 per policy. 6 is the premium you're paying for one policy. So, and you expect to receive, let's say, 75 per individual claim whenever you get that. And then for the second one, you're paying 3,900 and you're getting 150. So here for the second arrangement, it will look as more value for money. I'm just comparing the ratio. Actually, what you need to do is you need to find expectation Z, multiply with 500 and then with 0.25. And then you can make a sense out of it. You know what is the premium you're paying and what is the expected amount you expect to receive in that particular policy. My essence is value for money, so we can just work with the ratios as well instead of using the exact value, because 500 and 0.25 is something which will be same under both arrangement 1 and arrangement 2. Then we have question number 8 over here, which is from Kaplan-Meier method, I will say. So question number 8, part 1, median comes out to be 9. Part 2, this is the structure. These are the survival functions which I'm getting. And as per this, the median is coming out to be 13 itself, because till time 16, the values were more than 50%. 50% has been crossed first time over here. So it's coming out to be 13. This is question 8. And then part 4 is explaining the reasons for difference. I mean, again, this is something which have been tested in the past in IOPA as well, so you could refer to it. Question number 9, it's from Popula. We have two companies. We also have the Kendall Store. So this is xi t. We have this function. From this, I find the inverse function. I get xi inverse t. Note that the question has mentioned to use the generator function. Else, I could have used directly the formula as well. But because they've insisted on using the generator function, this method I feel would be the right approach. Which should fetch the full set of marks. So here we go, and then we have Kendall Star is 0.08 for we have a Clayton copula over here, right? So for a Clayton copula, it's alpha by alpha plus 2, which is my tau. This should be equal to 0.08 and alpha will be coming out as 4 by 23. And once I substitute this, I'll get the value of my popular, which is 0.002393. Next question number 10 again, something called Hindustan Premier League on the lines of Indian Premier League. They have taken LSG, which is Lucknow Super Giants, GT, which is Gujarat Titans. And what they have done later on is they have kind of gotten something which is currently do not have, is a kind of a bowl out thing, which was there probably during 2007 or 8 or so when T20 was introduced. In case of tie, there used to be a bowl out, and if you would remember, India did win a particular bowl out versus Pakistan, probably in the league game. They were in the same group. That is what I recall right now. And this sort of question, if I recall correctly, has been tested previously in IA as well in similar lines. But here, what I'll say is this is more, on the lines of tennis question. Advantage, dues, disadvantage in this format. And the values they have taken has been directly picked up from an IFA past paper. And I'll mention the question number as well. So this question, you all could refer to IFA. Paper CT6, September 2007, question 9. There was Andrew, there was Ben. Probabilities, if I recall correctly, were same. 0.6 for, one of them to win a point, 0.4 for the another. And in this format, they had to model it. So this question is exactly on similar lines. Although it's tennis or cricket, but the model state structure is exactly the same itself. So, this entire part could be tested. The 5 states will be there. Transition matrix comes out. 90% points needs to be paid, the long run probability and the comment part, so on. So it's exactly similar. So, what my experience has been in this session is looking at these papers and even few other higher papers, that IAI has been, giving a lot of questions which, answers of which are directly there in material, or a lot of them are from past year papers of IAI or even in fact IFO itself. So, ones who have prepared well, even just do not know how to solve it, just because of practice a particular question, I expect that you should be able to replicate the same in examination, at least the well prepared students. So again, this question a lot of you might have got. Some of them who don't watch cricket, don't follow cricket, they will see cricket, they will get, oh, I don't know cricket, I can't solve this question. It's not the case. Could have done it. Then question 11 is MCQ based. So let me quickly go through the answer key for same. A, B, C, and C. And then finally, we have question number 12, which is from graduation. So female members of a medium-sized pension scheme, we could use graduation with reference to standard table. Young population of a country, in order to study accident harm, we can use parametric graduation. Entire population of a large developed country, so we need to use basically the third method. Okay, I'm not getting the name right now. We had parametric, graphical, standard table, and then we had using splines. Correct, right? We need to use splines wherein the data sets are divided into different sections, and for each section we use a particular, let's say, polynomial or any other formula to graduate it. So it's of 3 marks. It's direct, straightforward. So overall, although the questions were similar, but due to the printing errors, all so and so things, students did struggle to complete the paper or even attempt a meaningful number of marks in this particular paper. So let's hope for the best, and let's see how I addresses it. I will also just ask a lot of you to raise this thing with II through email or any other forum. There has been this sort of printing mistake. I mean, this is something II should have taken care of. It's not expected because it might be very difficult for students then to solve it, and they should also come out with a lot of transparency as how are they going to go about marking it, because the examiners, I mean, I will say it's not prudent for us to assume that the examiners will spend time to see, what student has assumed and what sort of answers they're getting. Different students might have assumed different things. And I really don't expect, II to have covered all these such scenarios. If they do so, well and good for all of us. But given my past experience, personal experience, as well as, seeing my colleagues sitting for II for the past 5-10 years or so, I don't think their marking schedule is that well structured, covering a lot of scenarios. So do raise it as well. So this is the end of this particular video. I hope you all did find this video extremely useful. Please don't forget to like and comment on, like this video, comment on it. Do subscribe to our channel so that you are updated with all the latest content we have. And in case of any other further queries you might have with respect to paper, feel free to comment and we would be getting back to you through it. So thanks everyone.